Okay, what do we see here? Okay, well, we see that probably gonna have to do something about this integral. We can't just do it straight up. Why? Well, think about this. If we're integrating over this function, right? Meaning, just think about this function alone. 1 minus x squared. What does that mean? So if we're, like, I don't even know how that really looks like, but just imagine some sort of graph like that. Okay, that's probably not even it at all. But we know it goes from 0 to 1. Okay, that's the graph. And you're integrating, meaning we want the area under this curve, right? Now, note that we go from 0 to 1. And this is integral, meaning we go at 1. We're here, right? It's a solid point. Now, if you put 1 into this graph, whatever this graph is, again, I don't know how it exactly looks, but you get 1 minus 1. 1 minus 1 is 0. Square root of 0 is 0. 97 divided by 0, that's not good. Okay, so now that means that we need to start thinking in terms of limits, right? So now I'm going to erase this, and I hope everybody understands why you can't just go about this integral and do it like normally. Now, this integral isn't too bad to solve. All you have to do is look at your table of integrals, and then you would see a formula, probably like I think we're going to use some sort of tangent, arctangent, or something like that. I don't exactly know, but I'm just going to rewrite this as the limit as t approaches 1, integral 1 to 0, oh, not 1 to 0, t, and 97 over 1 minus x squared dx. Now I literally just have to search this up because this integral shouldn't be that bad to actually do itself. And yes, I see it, see the answer. This is going to equal to the limit as t goes to 1. Now I'm going to write this lower actually, so it doesn't get out of frame. This is the limit as t goes to 1. And the answer for this guy, all you have to do is use the integral table like I've been saying. And where is it? I just lost it now. Okay, yep, it's equal to sine inverse 1. No, inverse. Sine inverse x. God, I don't know. I literally have this one memorized in my head. I don't know why I'm struggling to recall it. It's funny. Sometimes you don't need the integral table. You just need to use your memory. 97 sine inverse of x. Right? That's it. And it's being evaluated from t. Limit as t goes to 1. I'm going to erase that now and say t goes to 1 and 0. So this is it. Now I'm going to rewrite this as 97. And then limit as t goes to 1 for sine inverse of t. And then minus sine inverse of 0. So this is it. You're using the proper notation right here. Okay. As t goes to 1, so basically all this is 97 sine inverse of 1 minus sine inverse of 0. Okay, now I don't exactly remember what these guys are, but I do remember the unit circle, so I'm going to draw the unit circle. Okay, and I'm just going to put out right here, what is this guy? Well, 0 or 2 pi, and we know that coordinate corresponds to 1 and 0. What does this correspond to? Corresponds to pi over 2, and the coordinate would be 0 and 1. So let me just think about this. Sine inverse of 1. Sine inverse of 1 is the same thing as sine of x is equal to 1. So what is x? Right? And then sine inverse of 0 is the same thing as sine of x is equal to 0. So what is x in this case? And what is x in this case as well? Now we can use these facts. Okay, so where does sine of x equal 1? At pi over 2. So we're at pi over 2. Where does sine of x equal 0? At 0. Okay, so then our answer is 97 times pi over 2 minus 0, which is pi over 2. There you go. It's a nice little answer. Hopefully I did this. Hopefully I did this correct.